One of the new capabilities in SOLIDWORKS Flow Simulation 2015 is the improvements in how we can compare results across different studies. We now support different ways of looking at the data numerically. We already had the ability to compare the visual plots, but now when we look at the goal plots, we have the ability to look at it not only in the table but as charts, whether we look at it as curves or as bar graphs, to give us much more insight visually into evaluating the results. We can also plot goal curves or other curve data and compare it across studies. So for example, the velocity along a profile through the exit tube with great visibility and ability to go in and look at results in great detail. So just one of the great enhancements in Flow 2015 to help you in reviewing results data across many different studies. A great enhancement in SOLIDWORKS Flow Simulation is a new sliding mesh for time-varying simulations. This provides greater accuracy for non-symmetrical rotational flows, as well as investigating transient flow effects. Under the settings for the rotation region, you simply select the sliding mesh option to activate the capability. In this water pump model, we've set up the impeller speed, inflow volume flow rate, as well as indicated where the surfaces are stationary in the rotating region. We have access to a wide array of results to gain greater understanding of the pump performance. We can see the fluid flow relative to the current time position from a sectional perspective, results on the impeller surface, as well as flow trajectories relating to the global reference frame or relative to the rotation region. Because of the housing shape, we can verify fluctuations in time based on the impeller blade position. By exporting the results to Excel for all of the time steps, we can obtain cyclic fluctuations in the impeller torque, as well as in monitored pressure and velocity in the junction of the exit duct to the impeller housing. We can verify that this is indeed caused by the blades passing this area by determining the period of the cycle. Based on the RPM, we can work out the rotating frequency, and from that the time period per blade, and compare it to the numerical results. We can see that we are in a couple of percent of the input, which is limited by the time step used for the saving of results. However, the best way to visualize the results is with animations by using the Flow Animation Wizard to capture results over the saved time steps. This can clearly show characteristics in the flow. In this instance, the flow variation as a solution reaches a steady state. In this mixer, we have one fluid being blended with another, and can visualize concentration distribution variation with time. These time snapshots can showcase interaction between the rotating blade and the added fluid. And again, visualizing results through the animation delivers far more understanding. The new rotational sliding mesh capability enables you to accurately and easily evaluate time-varying flow performance of your design.